turn that down, throttle down. Oh, I shouldn't get some noise. Yeah, so I'm making some upgrades. Let's see. I've got to wind some coils for this thing because the coils that are in there at the moment, they're not balanced properly. So I thought what I was thinking of doing was just basically filming the disassembly. I could still turn this thing on briefly. Let's see. Right, there it is. Put the camera over here. 92 milliamps. I put the trimmer back on here, which I was showing. Let me just tilt this over without pulling everything off. So I put the trimmer back on, the adjustment, the variable resistor, as I was showing in the previous video. The soldering came off when I was trying to tweak it. So I've got it back on. Let me just show you quickly before I start disassembling this thing. Oops, the wire come off. Let me try and get this other wire on. Oops. Come on, you bugger. Ah, this wire is too freaking short. Where's my scissors gone? Scissors. Oh, there you are. This freaking wire's too short. I need to trim a bit more wire off here. Oh, cut the damn wire off now. You twat. I'm trying to do this without cutting the wire itself. Right, that's it. I've got a piece of plastic off. I thought I'd do another with this douchey, horrible, crappy camera. Right, if I can get this on. Oh shit, come on. Yeah, I've been watching Lewis Rossman actually, and now my language is deteriorating watching him. Oh, I can't get this on. Come on, you bugger. Oh, actually, I'll wrap it around there. Oh, that's better. Right, I've got my trimmer on. Let me just move camera a minute. Bring it around here a bit. Can't see it. Let me just move this scissors out of the way a minute. Before I start to disassemble this thing, let's move this to the left. See if I can get it. Oh, damn it, is it closing up on me? Oh, no, it hasn't. Right, the meter's down there, that's 40 milliamps. Oh, I'm blocking it now. Oops, let's move that back a bit. I'm trying to get this meter in. I'm too close to see now. So at 40 milliamps, sorry, 92 milliamps output, 40 milliamps on the input. Actually, if I stick this meter over here, will that work? Right, that's the output. That's the out. Oh, block the other one now. This is ridiculous. You can see it now. Right, 92 milliamps output, 40 milliamps input, and I'm going to trim this trimmer. Oh, my hand's in the. Is it in the way? Yeah, it's. Let me just do this with my left hand, just a minute. Do it with my left hand. Right, as I turn the trimmer. I'm on current, I want to be on voltage. Right, put it on voltage. Are we all connected? Right. The voltage should go down as the current on this trimmer as I turn this trim pot should drop. You see it slowly go down, and the actual input current will go down. Right, it's dropped down to 40 milliamps, but it's not much of a change. So yeah. So when I short out the output coil, this coil here, the actual input current drops a bit. Let's turn the variable resistor up a bit so we get about 1 volt on here. Let's see if we can get it on to 1 volt if I can. 1 volt AC. Oh, it's too far. Right, that's close enough. 1.09 volts AC on the output, and the input current is at 50 milliamps, and the voltage is still at 40 volts, which is being switched by my H-bridge circuit, which is down here, which is behind this meter. Let's turn the voltage. I really want to be able to can't say the word. I really want to digitally measure the actual current to be more accurate. So what I'm going to do, actually what I'll do is I'll unplug these leads here, because this is clipped on here, and if I unclip it the other wire comes off. So I'm going to disconnect the 2 meter leads that are here without pulling my wires off. So I'm going to unplug these 2 leads. I'm going to switch this to current. I'm going to measure the input current on the H bridge. So I'm just going to unplug that. Oh shoot, does that come off? No. Right, I'm just disconnecting this. Right, I want to put this on DC, and I want it on current. Now this voltage booster, which steps up 15 volts to 40 volts, I was looking at the meter across the room. This thing actually uses 100 milliamps even when it's not powering this. So technically speaking, this H bridge is only using 100 milliamps. So right, I'm on the 200 milliamp range on this meter. So what I've got to do is, flipping wires tangled up. Hang on. So what I've got to do is I've got to unplug one of these wires that are supplying the H bridge. Right, I need to get my big crocodile clip. Right, so I've got a big crocodile clip here, which I'm going to clip to positive on my meter, which I'm going to clip to the positive wire coming in. So I've got to disconnect the white wire, which is positive, so it's going to stop working in a minute. Well, the H bridge will keep working, but it's not going to get any juice. Right, so I've removed the 40 volts coming in. As you can see, the meter's in the way. The 40 volts that was going to the H bridge has now been cut off. So I'm going to connect the red wire, the red lead, which is on current, to the white wire. Right, and I'm going to have to hold the black lead in the positive input of my H bridge. Oh wow, it's gone over the limit. Just a minute. I'm in the right one, yeah. Oh, I need to be on the 10 amp range because it's going over the limit. 10 amp range. Okay, so, wow, what? Oh, it's dropped now. That's weird. That's interesting. What's going on? Are we on the right range? Oh yeah, because it was charged at the capacitor. So it's actually reading 50 milliamps. Wow. Wow. So I can go back in the 200 milliamp range. Just a minute. I want to be more sensitive. So let's just give it a chance to stabilise, because it's over the limit. If I give it a minute or two, it's settled. There we go. There we go. Right, we've got a very accurate reading on the actual current. So when my meter over here says 50 milliamps, we're actually getting a more detailed reading now. We have 55.7 milliamps DC going in to supply the H bridge, which is driving the actuator coils. Right, obviously it was high because it was tweaking, it was charged up the capacitors and everything. Right, so let's tune this. So when I turn the resistor, the variable resistor, and we put more load, let's see what current is reading on here. So remember, I left the trimmer at 1 volt, so it's under load right now. It's the actual output on that was 1 volt. So I have to turn this trim pot, basically open it up. So what I'm doing is I'm turning the trimmer to reduce the load on the output, the resistor on the output coil. So I'm turning, oops, come on, bloody thing. The screwdriver's slipping, might get it in the hole. Right, so I'm reducing the load on it. We're fully open now. So the variable resistor is now fully open, and our current is 55.9 milliamps on the input. Now let's turn it halfway. So the 470 ohm trimmer is halfway now, so half of 470 ohms, I can't work that out, it'd be about 230 maybe, 235 is it? Yeah, 235 ohms DC resistance at the moment. So let's go up, it'll be, I'm increasing the load now. As I increase the load, $57, right, 57. It actually goes up a bit, then it goes back down again. That's interesting. So 53.4 milliamps on the input, and that the variable resistor. Let's fully close it. It's fully closed now. Open it up a bit. Slowly open it up. And as the resistance is increasing across the load, the output current is going, sorry, the input current to the circuit is actually going up. Slowly opening, increasing resistance on the load. 56.8. We're about halfway now. I'm going to open it right up to 470 ohm resistance. Slowly. Right, so fully open at 470 ohm 470 ohm resistance DC across the coil, and the input current is now at 55.9. Right, very, very interesting. It actually seems to go up, then go back down again. That's really, really interesting. Now I've been holding this lead on all this time while I've been doing this. That's fascinating. I seem to be right in this sweet spot. Anyway, I've showed you what's going on the digital meter, so you can see exactly how much current is supplying this thing. Before I disassemble this, I wanted to do that before I disassemble it, because I've got to put the new upgrades in, which I've been making, which are these things. I'm printing out the new cores that are going to go in the middle, and then these go inside the black rings on here with the black concentric magnets. So yeah, I've got to put these new upgrades, which should improve the coupling a bit, but I won't be able to improve the coupling very efficiently as long as I've got these 4 bearings in these corners, because yeah, I'm going to switch my meter to volts. I'm going to unplug that, take this thing off, stick this back on the well, actually I'll leave it off now because I'm disassembling it. Right, I'll just put my meter out of the way. I need to put this wire back in there though, because it's floating around, it might short out. Bang! I'll just stick that back in the hole. Oh, I hate these clips. When you tighten them down, they warp a bit and then you can't get your wire back in. Pretty crap, these connectors there. Get in. Damn it, won't go in. squeezes. Ah, it's in now. Tighten that up. Right, that's in. Okay, so you saw an accurate digital readout, because this is not very, doesn't have enough digits after the 50 milliamps. It's a very crude measurement. So we had a very accurate digital multimeter measurement on that. I need to move this over here out of the way, further back, so we can get a. That's better. I'm going to take this off here because turn this thing off actually now, because right. So what? I'll turn the big power supply off. Right. Oops. Yeah. Okay, I'll disconnect all this. As I said, these coils, these two input coils, there's two coils on this side, two coils on this side. These are the actuator coils, and there's this pair is matched, this pair is matched, but between the two pairs they're mismatched. So these two pair are mismatched with these two pair. So the impedance is different. I actually measure that when I take them out, so you can see what the impedance is of the coils. This is what I want to be doing right now. So I'm going to disconnect all these coils. Come on. Right, that's disconnected. Take that off. Take that off. Take all these wires off. Right, the H bridge is completely isolated now. Oops, my capacitor just fell on the floor. Where'd it go? Where'd it go? There you are. Right. Okay, I'm going to do a DC ohms resistance on the coil, so you can see what I mean about them being mismatched. That leads out of the way. I'm going to ohm out the coils, because that's something that you're probably interested in. Remember, there's two coils on this side which are actuating, and they're both in parallel. So let's go to ohms. We're on DC ohms. This pair is measuring 9.7 ohms. If you remember, I was saying, I think previously it was about 8 ohms or something. Well, it's actually 9.7 ohms with them in parallel. These two coils on this side are 5.4 ohms. So these two coils, DC resistance in parallel is 5.4 ohms, whereas these two are 9.8 ohms. That's within parallel. Each coil, I've twisted the wires together on here. I'll leave them anyway, but don't let it. Let's see. I turn this meter off because I want to get this out of the way. I need to get this capacitor off here. What I really want to do is put these capacitors closer to these coils, so that, yeah. The reason I'm recording all this stuff, what I'm doing right now, is because if I make changes and the thing doesn't work anymore, or it changes the behaviour somehow, I want to have a video record of what I actually did. Oh, I was looking for you, you twat. Yesterday I was looking for this bit of steel. I was looking all over for this bloody thing, and it was under this bit of foam. That's what you were, you little bugger. I couldn't figure out what I'd done with it. So, right, the trimmer, I'm just going to leave that on there for now. So all of this, it literally just pops apart when I take these elastic bands off, you know. So what I'm going to do now is I'm going to take this elastic band off here, like that. Turn the thing over. Take this elastic band off This one, now the whole thing should just pull apart. There we go. And there's my coils that I made, which are in this one. That's the output coil. You see all the we're wrong way. You see all the steel welding rods in the core material, and that's the sleeve that goes around the inside cores, which intersects with these ferrite rings, these transformer core rings. That's the output coil. Take it off. There's the trimmer on it. Oops, too high. That's the output coil. Nothing special. It's just one I took out from my chuck that I wound earlier. So take this bobbin off, which is got no wire on it, which is another one that needs winding. It also has the welding rod stuff in there. So that's that. So I disassembled that. Now, and this is all adjustable. So like I say, all I have to do is pull these apart on my actuator, which spins around on them two ball bearings in there, which you can probably see. The whole thing just spins around. It's literally ball bearing coupling. So I just pull this. Actually, I'll do it with this one first. They're both the same. This one's the same lot. There's rubber bands on here as well. Take them off. Right, take all the rubber bands off. This one's also the same. Just pull these apart like this. Ball bearings fall out. There's my actuator coils, and now the reason for improving this is because the coupling's very loose on here. So I just, if I twist this slightly, there's my magnet rings on the inside with the steel. I've got rods actually. I've got steel rods. There's 4 steel rods in these slots from the middle concentric to the centre. All Nico magnet, which is in the middle. Now the coupling is very weak between these magnets here, because there's an air gap basically between there. I don't know if you can see that, but there's an air gap between here and this magnet here, and this magnet's closely coupled to these steel rods. Now obviously the reason for the improvement is that the new ones, get one of these, you'll see the difference is I've got these steel things in there. So I'm printing out the new cores that are in the middle. Now I've got 2 options. I can push out all these steel welding rods that are in the middle. I didn't ground these down, it was so basic, you know. I haven't even ground them flat, so they're all different lengths, so it could be erratic. So I mean, you can push them all out and stick them in the new core that goes in the middle of here, or I could use some of my steel laminations, which are these. If I could get one of them off here, which are these laminations I had laser cut a few years back. I could either use them in there instead of my steel rods. I don't know yet. I haven't decided what to do with that yet. So, but this is one of the coils on this side. Turn it around. I have to twist this, otherwise I might pull the bobbins apart. And there's the other side. So there's just a ferrite ring in the middle there, and it intersects with that one. And they're both basically the same. So I twist that on there like that. That's one. That disassembled. 2 ball bearings, and these are adjustable. Just pull them apart or push them together like this. Nothing fancy, but these are the reasons why I've got such a lot of losses, because I'm using these ball bearings intersecting with ferrite rings on the top and the inside, and so there's a lot of air gap there. I don't know if you can see this, but there's actually a big air gap. If you get it on the side, you can see. Actually, maybe I should shine a torch in there. Right, so if you shine a torch in there, you should be able to see. Oh, it's a bit too bright now. Be able to see the air gap. It's probably too bright. Let's try. Yeah, you see the air gap. There's a lot of loss there. Too much, really. Right. So I've got that part. Take this one apart. I've got an elastic band still on here. Pull this one apart like this. There we go. Oops. There we go, I've got the other one off as well. This is the 450 turns of 30 SWG wire on each one of these. Yeah. I couldn't remember how many turns was on there before, so yeah. So there's my two end bits all dismantled. So yeah. I'm going to stick these out of the way because I've got to redo the middle ones, so I'm just going to stick all this lot out of the way for now. So what I've got to do, I'm going to dismantle this disconnect this middle one, because I really want to wind new coils for these so they're all the same. That's disconnected, take that off there, take that off there. Right, so there's two coils that were wound previously. I can't remember how many turns that I put on there actually. I don't think it's 26 SWG on the low impedance side anyway, 26 SWG for the low impedance, and it was 30 SWG for the higher impedance, but there was 450 turns on there. I actually counted those. So, but it's the same amount of copper to fill the spool up, so you could probably work it out how many turns you could get on there. If you're a mathematician, you should be able to work it out. I didn't count it because I was using my coil winder, and I just couldn't be asked to count it. I just made sure it was flush with the lip of the bobbin when I was winding it. So they're out. Put them out of the way. Dismantle these because these are in parallel. That's off. Ouch, my finger's still bloody raw. I've got a hole in it and it just, it's trying to heal and I'm knocking it. Alright, I've got them apart. Twist my coils off. Got them off. Those are off. These are all raw now, so I can go and sort these out, because these are what I need to do some work on right now. So I've got to pop out. There's magnets on there, so as you can see, magnetic cogs now. So I'm going to push this thing out like this. There we go, I've got my inner out. Take this one, push this one out. Got my inners out of that. Those are my concentric 8 rings. I'm going to stick them somewhere out of the way for now. Oh, actually, I need one of them because I want to test fit it. So, right, here we go. I'm going to test fit it on here. They've got a fit inside here, like so. Get it right way around. I want to get the pole right. Which is the right one? Just a minute. It's a bit hard to tell with all this polarisation, right? So that's south. That's south. So that's south with that south. So that's where it goes in like that. I hope it's going to fit alright. Oh, perfect. Fits perfectly. So the new inserts are going to fit bang on. And they weren't too much effort to get them in as well. So that's one in. Let's just try the other one. I need to. Right, so it's a bit weaker, these little magnets inside here. Oh, I think that's so. I'm not sure. How do you see on there, because it's so weak, because the little magnets inside are very weak. Oh, that's south. So that's south. I need to mark these. So what I'm going to do is I'm going to colour code these, because I'll get them in first. Alright, I've got that in. What I'm going to do is I'm going to see, where's my gauge gone? Alright, so that's, oops, so that's red. Skip one and it's red. Skip one, red. Skip one, red. Right. Do the other side as well. It makes it easier when I'm taking them out to match, get the poles all right, instead of having to use this damn thing every time. Right, I've marked all those. I need to do this one. Oops, tweezers, go away. Right, I colour coded them so that I can take the middle out with it and knowing which way around which. I can't really colour code the black pepper. I made these rings about 5 years ago or something, and they're actually magnetite mixed in with fiberglass epoxy resin, and they're very tough, very hard material. They're actually quite brittle actually. If you drop them they can shatter, so I've got to be careful with those, because they're not. These black rings were not 3D printed. They were originally 3D printed, but I made a mould, a silicone mould, and I cast them in resin and black magnetite. Right, so I've got these. I'm waiting for the prints to finish, then I can put the new cores in. I can't get these out because I stuck them in. I think I stuck them in with. I don't know if they'll pop out actually. No, I don't think they will, because I acetone them in, so they're going to be part of that now. They're going to be permanently part of that. But these middle bits do really want grinding a bit. They just want grinding flat. I never did grind them flat, but I could take them out of here and put them in the new inserts in the middle if I want to do that. I'm interested to see if these have been. Oh yeah, the old Nikos are completely demagnetized now. Check that one. Oh, that one's still magnetised. That's interesting. So I didn't provide enough AC to actually flip the Alnicos. So technically speaking, the Alnicos weren't doing a damn thing, because that's still magnetised. It should have become, with AC, it should have been demagnetised. But look, it's still magnetised. It's holding on to my tweezers. That one is. That one isn't. You can see. That Alnico's not been polarised, but if I get some magnets here, some neodymium magnets, separate them, put it on here like that. Now the Alnicos will be magnetised. magnetized. Let's take that off. Ooh! I don't want these flying across the room. Come out. Now these old Nicos, this old Nico is magnetized. Let's get that out of the way. Oh, not very much. A little bit. A little bit magnetized. Yeah, you've got to get them really close to the magnets to magnetise them. It takes a lot of energy to magnetise old Nicos. But so this proves that the Alnicos themselves are not contributing to the behaviour of the device, which means they don't even have to be there. But anyway, they are there. I put it in there for an experiment. The Alnicos are not flipping poles, so the fact that's why I put one in that was magnetised, one in that wasn't magnetised, because when you turn the device off, the power is cut to both these at the same time simultaneously. And I wanted to see if the Alnico that was magnetised would become demagnetized versus the demagnetized Alnico would become magnetised. Well, obviously that experiment, I can push this out actually. So we'll take the Alnico out of this one. There's the Alnico, and that's the magnetised one. You can probably just about see it. It's not easy to see actually. Oops, move that out of the way. But this is a magnetised one, I think. No, that's the fully magnetised one. This is partially magnetised. If I get these magnets, stick it on there, and the other side. Now this is extremely magnetised. And you can see it's a lot more stronger now. It's a lot stronger now. Put this magnet there a minute. Get my gauge. You can see it's deflecting. You can see it's deflecting it right now. Get my where's my magnets? Get them. I'm going to just push until it feels like the field collapses. There, this one. That should be demagnetized. Now when it is, put it in my hand. It's completely, well, almost. It's very weak now. It's very weak. Demagnetize it. Now it should be very strong. Yeah, a lot stronger now. A lot stronger. You can hear it by the click sound. Let's demagnetize it again. I might have gone too far. Nice, demagnetized. The other side's got a bit on it. You can tell it doesn't click now. Very weak. As you can see from the gauge, there's nothing on there. Let's put it about there. Turn it around. Nothing. Right. So yeah, you saw it dismantled. Anyway, I think that's it for now, because this print's going to take probably another 2 hours or maybe an hour to finish. And I've got a lot of metal work to do with that, and I'm not looking forward to it because my fingers are already still sore from the other day. Yeah. I don't think I can push them out. I would like to put them in there, but the acetone will have made them one piece now. I'll just have to wait for the print to finish. And yeah. I'm glad to get that thing out of the way, because I had nowhere to use I had no room under the table to use my mouse. It was just cluttered to hell at the moment. Anyway, that's it for now.